Hello, algebra students. Welcome back to another video lesson for today, Monday, the first day of February. Again, using two screens, so if I'm not staring at you, it's because I'm looking over here on the screen and whoa, sorry, there might be a bright forehead glare here. If there is, I apologize. Anyway, today we're still focusing on box plots. Can we construct them? Can we identify the 5-number summary? What does that all mean? And then how do we identify outliers and calculate them perhaps? So let's go ahead and take a look and see what all of this means. So this box plot that you see on our next slide might be slightly different than the ones that you've seen in the past. So take a moment and answer the question that pops up inside here of Desmos. Hopefully you noticed that there is what we call a circle way out here that's not necessarily attached to the end of the whisker. Right? Everything else is attached minus this small circle. This, when we look at box and whisker plots, is how we can identify that this is physically an outlier because it's not attached to the rest of the data. I'm going to quickly go through how we can calculate, because there's a physical way, mathematical way that we can actually calculate an outlier. And that's by doing the following. We calculate the IQR, which is the interquartile range. So we identify how far is it from Q1 all the way up to Q2. How far away are they? And this one looks like it's about 8.5 to 17.5. Roughly 8.5 to 17.5. So that would be an IQR of 9 on that other slide. We multiply the IQR by 1.5. So 9 times 1.5 would be 13.5. And then what we do from our boxes, right? We take the end of the box and we take this number and we physically look 13.5 this way, and then we physically look 13.5 this way to create what are called the fences. The fences. So we said this was at 8.5, and this one we said I think was at 17.5. Okay, so we go backwards 13.5, which is like -5. So that's one fence out here. It's called a fence. And then we go 17.5 plus 13.5, which is like 31, and we draw another fence. Anything that is outside of 31 or -5, those two fences, if it's outside the two fences, it's an outlier. Which is why, if you look at this point, which is like 35, it's outside of that fence, it is considered an outlier. Now, it's complicated. It's a process that you have to go through. Here's the good news. We're going to use Desmos to do all of this and calculate those values for us. So you're going to get some important notes coming up here about Desmos and how to use Desmos to create those box plots. Make sure you jot these notes down. All right, we're going to use page number 14 of the packet. So I am in your stats packet, page 14. Again, you don't have to print it out if you don't have access to a printer. I mean, it's helpful, but you don't have to. And then what you're going to also want to make sure that you do is, at least jot these down so that you can figure out how to enter them into Desmos when that time comes. So we are going to take this information and we're going to go and open up, Desmos.com. And then we're going to plug this in and work very similar to how we have in the past. Once we are over there, here's what we're going to follow. Enter the data just like we have for mean, median, and mode, for histograms, for all of it. It's the same concept. But then we're going to use the word box plot. Last week we used histogram to create a histogram. Now it's going to be box plot of whatever letter, offset 1, height 1, and then we want to make sure we keep the box checked because that's going to then use a dot to show us the outlier. So write those steps down. You should pause the video, write those steps down, and then we'll look over at Desmos together. All right, hopefully you got those steps down. What we're going to do is we're going to jump over to Desmos. Now, again, I've taken the time and the liberty to go ahead and make sure that I typed those out just so that it's a little bit easier for us to see. Notice we're going all the way from like 29 to 50. You don't have to have them in order. You don't need to. You just need to be able to identify what's the lowest and what's the highest. I'm going to click Enter. Now, what are we trying to create? Box plot, parenthesis A, offset 1, height 1, exclude the outliers. But Mr. G, it's not showing. What do I need to do? Hopefully, you recognized that you need to change the x-axis, the left and right axis. So I'm going to change the left and right axis. The lowest we said was 29, so let's go from 15. The highest, oh, come on now, was 50, so let's just say 60. And what do you know, right? 50 was the highest, so there's the end whisker for 50. 29 was the lowest, so there's the lowest. So we've got our box plot. Notice there aren't any circles on the outside of either one of those. I know 29 is the lowest. I know 50 is the highest, and since there's no circles, there's no outliers. Now, how do you figure out what the 5-number summary is? There's a nice nifty way. It's called stats, S-T-A-T-S, of A. And look at that. It gives me the 5-number summary straight up for us. The minimum 29, Q1 is at 36.5, median is at 40, Q3 at 46, and the max is at 50. So Desmos does a lot of the work for us. I could even tap, and I could type and overlap a histogram on top of this if I wanted to. And there's a histogram that shows it as well. All right. So Desmos is going to be very, very helpful for tests, for target practice, and things of that nature. But stats of A gives you the 5-number summary. Box plot of A actually draws the box plot. You just got to change your window. And that's really all this video is making sure that you can go in and use Desmos to help you create that and identify where or when that particular outlier might be. So for example, let's just add a number in here really, really quickly. Let's just say 60. Whoops. What did I type wrong? Not 06050, comma 60. Notice that didn't even give us an outlier yet. So maybe we'll add one on the front as 20. And that still didn't give us an outlier, right? So maybe we just need to go 28. So we don't have an outlier yet because I don't see an actual circle. Once you see that circle, that's how you can identify that you would have the outlier. Make sure if you have questions after watching this video that you reach out. I hope you took notes. I hope you wrote down some of those examples and especially the steps on how to use Desmos to create the box plot. Until next time, everyone, stay safe.